You might have seen in my older video, which is quite old, that I proved that 0.9 repeating is equal to 1 with the infinite geometric series formula, but I never actually derived the formula, but I'll derive it today. So I'll just show you guys my method of proving this mathematical paradox. So let's just define our condition first before we derive the formula. Let's say that, just give me a sec here. Let's say this. If the common ratio is less than 1, then the limit as n approaches infinity is definitely going to be 0. So what I mean by that is that is eventually going to be 0. Now, what do I mean by that? Well, I'll show you with an example. Let's find the limit of 1/2 to the n. So let's write lim as n approaches infinity of 1/2 to the power of n. Okay, well, what do we do here? We can expand the n into the fractions, so we can say Tn is 1/2 to the n, which is just another way of writing 1 over 2 to the n. Now, what happens as n approaches infinity? Well, the denominator becomes infinitely large as n increases. So what I can say is the limit as n approaches infinity of 1 over 2 to the n is in fact equal to 0. So like I said before, if the ratio is less than 1, then limit of, here, let me just write this over here. Lim as n approaches infinity of r to the n will definitely equal 0. Now let's derive this. Let's say the sum of an infinite series is a over 1 minus r. That's what I said in my old video, but let's derive that. Let's just let's go back in time to when people were just figuring this out. Let's go to Zeno's paradox. Let's take one of his examples here. He was challenging space by saying, if there's a man standing here, he cannot walk here, because to do so he'd first have to walk half of this distance, and then half of this distance, and then half of this distance, and then half of this distance, and that just goes on forever and ever and ever, and it can never end, and he can never reach the wall. But that defies common sense. So if we were to represent this as a series, we would say S1 is 1/2 because he walked half the distance, and then S2 is 1/2 plus 1/4. And that would be 3/4. And then S3 would be 1/2 plus 1/4 plus 1/8. So in decimal that'd be 0.875. And then the next would be S4 would be 1/2 plus 1/4 plus 1/8 plus 1/16, which is 0.9375. Now, what happens as that approaches infinity? Well, the sum to infinity of that is 1, so he eventually does reach the wall. So if a series has a sum, and in this case it does because r, absolute value r is less than 1, it's called a convergent series. If not, it's divergent. So if we were to take this series, for example, 1, 2, 4, 8, 16, 32, there's no sum to that. The sum is infinity. So let's derive this that I was talking about up here. Let's say the nth partial sum of a geometric series, Sn, is a plus ar, which makes sense, plus ar squared, because all we're doing is multiplying r once more onto our first term, and that just goes on forever. So we can make that into a formula to say ar to the n minus 1. And that's our general formula. So let's plug it into that. Let's say Sn is a times 1 minus r to the n over 1 minus r. Okay, well, we know that if absolute value r is less than 1, this will be 0. So that goes to nothing. So we're left with the limit as n approaches infinity of the sum equals the limit of a times 1 minus 0, because r to the n is 0, over 1 minus r. So we're just left with s equals a over 1 minus r. So let's apply that to 0.9 repeating. Let's say, okay, what is the sum of this? 0.999999. That goes on forever and ever and ever. And we can write it like this. Let's write that as a series. Let's say this is 0.9 plus 0.09 plus 0.009 plus 0.0009, and that just goes on forever. So let's plug it into our formula. Let's say a is our first term, which is 0.9, what we have here, and r is 1/10, which is less than 1. So this does have a sum to infinity. R is 1/10. Let's plug it in. Let's say what we just said. S equals a over 1 minus r. So let's say the sum of all of this is 9/10, like we had here. 9/10 up here over 1 minus our ratio. And our ratio is 1/10 because 0.9 times 1/10 is 0.09. 0.09 times 1/10 is 0.009, and that just goes on forever. So 1 minus 1/10. So what do we have here? Well, we've got the sum is 9/10 over 9/10. And anything divided by itself, with the exception of 0, is 1.